Could you imagine today's world without being able to see everything from above? As industrial development has progressed over the last few centuries, no longer do we need to be present above the landscape inside an aerial vehicle in order to access it. Enter the drones.
Here at the Department of Electrical, Power Engineering and Mechatronics, we do cooperate with different drone companies. For some companies, we're helping to test facilities and parts of the drone. For some companies, we're helping to test the software.
Until lately, the wider usage of drones was considerably limited due to the restrictions of battery life, which would render the machine inoperable within 10 to 30 minutes. TalTech campus is able to boast, with a drone that the students could use to send a package to their colleagues in Finland and Aalto University. Sending packages greater distances could even prove vital in some cases, in places without roads or remote areas, such as for the delivery of medicines in Africa or Asia, where these solutions are being tested. Yet the future of drone technology is even more promising when the regular battery will be substituted for hydrogen elements. Constantly decreasing availability of the world's freshwater supplies is most threatening to small island states, such as Grenada in the Caribbean, where the deployment of innovative technical solutions is critical in coping with the unavoidable effects of climate change.
In cooperation with TalTech, we at FlyDog are currently developing a water monitoring system.
One of the main objects of the research is the Internet of Things, IoT, application of the latest developments in sensors and telecommunications. New technologies help improve the reliability and durability of the water quality network, only at a fraction of the cost of the existing commercial solutions. Currently, the researchers lack knowledge of the effect of such climate changes, and TalTech is working hard to build dependable sensing systems which operate also in extreme environments. The total of 20 measuring points on Grenada's island have been agreed upon with the local partners.
This technology enables two-way communication between different sensors around the world.
FlyDog Marine develops monitoring solutions for the marine sector, such as fully customizable data buoys, vertical profiler buoys, and submersed profilers that fit a large number of sensors. Consider highly accurate and specifically customized sensors, giving you valuable real-time data for analyzing without even leaving your office.
We at FlyDog help engineer data collection solutions for TalTech researchers.
The sensors that have been developed, inspired by fish, are now in action in the port of Sillamäe. Many installed sensors along the quayside mean that the pilot gets data about wind and water currents and can take all this into account while driving the vessel to the pier. Why is it so important? According to worldwide statistics, most marine accidents happen inside the port or upon entry. In terms of marine safety, this is the most dangerous maneuver. This is an excellent example for a fish-inspired technology to benefit safety. Festo Flexible Manufacturing System is a concept that demonstrates what a real Industry 4.0 production line should look like. It is a distributed system consisting of modules, which can carry out different functions: storage, part processing, product assembly, and others. All modules are connected using moving robot platforms, which can transfer parts and materials between the modules. The purpose of the IVAR laboratory is to create virtual and augmented reality applications for industry. One of the main areas of research is the development of industrial systems called the digital twins. A digital twin is a virtual model of an industrial robot, whereas the real robot operates in synchrony with its virtual twin. This means that algorithms are used to connect various links and sensors of a particular computer model to a real robot, forming a pair of digital twins. Improving the control of modern industrial robots by creating digital twins allows better and safer control of technological devices in the manufacturing process.
Our newest factory was first built and tested in virtual reality as a digital twin. This helped us save time and money by allowing us to find possible future weaknesses and failures before actually moving into the new factory.
The third added value of digital twins is significantly improved safety. For example, no physical human presence is required to correct or reprogram robotics algorithms. The operations can be carried out virtually, such as by remote control.
In addition to daily research and development, our cooperation with TalTech is really an ongoing learning process.
Industry 4.0 truly is the future that is happening now. TalTech, constantly improving.